Hi all, welcome to Graphics Desk.
Now in this video we'll talk about how to draw orthographic projections of the given object. So what we have been given is, in the problem statement, this is the direction x in which it is visible. The angle of projection that we'll have to use is the first angle method. And what we have to draw is front view, top view and right hand side view. Now one thing interesting to note is that we have given the full length of the object, which is 40 mm, which means it is the length visible in the side view. The width of the object is not given, so we'll have to calculate that. Now this particular dimension is 26 mm, and what we have, this particular face has the width of 5 mm, which means the total length of the object or total width of the object is 26 plus 5 plus 5, which means it will be 36. So let me quickly mark this particular dimension as 36 mm. Okay, so what we have is now 40 mm is the length of the object, 36 mm is the width of the object, and total height is given as 45 mm. So in our front view, it will be a rectangle of 45 by 36 and all the geometry would be within it. In our right hand side view would be 40 by 45 and all the geometry within it. And in our top view, it will be 40 by 36. So let's draw the XY line and we'll start with the front view. So this is our XY and this is X1, Y1. Okay, now as it is a first angle method of projection, we will have our front view over here. Our right hand side view will be on the left hand side and our top view would be on this this section of the quadrant. So let's first build the front view with base as 36 mm and height as 45 mm. Let me draw the rectangle first with very faint lines and then we'll construct the geometry within it. Yeah, so this is the rectangle inside which we'll have our geometry. So let's see what all things we have given. Now this particular face, which is the front face visible in the front view, is at a height of 16 mm, and then we have this slant face, which is a slant face. It is essentially until the top of the object, but what we have been given is this particular line is 12 mm from the top, and this particular face, which will be again represented as line in the front view, is 20 mm from the top. So we'll have to draw a line at 16 mm, 12 mm from the top and 20 mm from the top. Okay, so now I have only marked these levels as these three lines, but to do the construction, we'll have to measure the horizontal distances elsewhere. That means distances in the z-axis. So let's measure that. So what we have here is, this is 5 mm from this face, again 5 mm from this face as well. Then we have this as 7 mm and the gap between is 12 mm. Now we already have calculated 36 on the basis of same. So we'll measure 5 mm from this side and 7 mm from this side. So let's measure that from both the sides. Alright, so let's mark the vertical lines from here, from these points. Okay, so what we have here is the first of all this is the opening at the center of the object with depth as 20 mm, which means this would be the solid line, and then we'll have this particular face as solid. So let's draw that. And when it comes to horizontal line, this is at 16 mm, which will form this face here. This line which will be connecting to these 2 points, and then we'll have these 2 points and these 2 points connected. And again, at the top, we have the solid line over here. Now, this is what our front view would look like. Now, we don't have any dotted line in this because the only possible dotted line is this one, which is essentially superimposing this particular solid line, so as the line opposite to this, this and this, but these are superimposed, so we don't have to draw these lines. So this is how your front view will look like. Now let's draw the vertical projections, and let's see how our top view would look like. So I'm carrying the vertical projections to draw top view over here. Now in the top view, it is 40 mm in the length and 36 mm, which is coming from the projection anyway. So what we'll have to have is, it's a rectangle, which is again a solid line first. So we'll have to measure 40 mm in this direction, which will be essentially height if we talk about top view, and 36 mm is already given to us by projection. So let me start with the line over here, and then let me complete the rectangle as 40 mm measuring from that. So our top view would be inside this rectangle only. Now what we have here is we have this dimension given as 30 mm. So we'll have to locate the center first, because this geometry is symmetric to this center. So we'll have to locate the center first, and then 15 mm in this direction and 15 mm in the other direction will give us these 2 points, and essentially these lines. There would be other on this side. This dimension is given to us, which is 16 mm. That means again from the center line, it is 16 on this side and this side. But we don't have given this particular dimension. So for that, we'll carry it from the side view, and we'll see how to get to that. But right now we'll mark the center line, we'll measure 8 mm to locate this face, and then 15 mm on each side to locate this particular faces. Now these 2 points are 8 mm from the center, and this point is 15 mm from the center. So if we draw lines from here parallel to y-axis, this would be the solid line, so as this would be, and the line which is 8 mm from the center, which is 16 mm, is basically 2 rectangles. That means this rectangle and this rectangle. So anything between these 2 projections and this line, that would be visible part. So let's draw that. Now I'm keeping it faint for now, because these faint lines would be made solid later on, because there are 2 projections that we have to carry from the side view into top view, which essentially is for this one and for this one. So let's go to the RHS view now. So let's carry the horizontal projections first, and then we'll carry the projections from the top view. Now to carry these projections in the right hand side view, we'll mark 45-degree lines. We'll carry the projections up until that line, and then we'll draw those projections vertically upward. Now let's carry these projections that we already have in our in our top view. And there are two projections that we'll have to borrow from side view into the top view. Now we have got our horizontal projections, that means projections from the top view until this 45-degree line. From these points, let's make vertical projections parallel to x1, y1. Now, our right hand side view would look like a rectangle and then half triangle or partial triangle on it. So this will be the face which will be visible. So this lines would be solid. The base would definitely be solid. 16 mm height, that will be solid, and this is where the line will come from the projection that we have taken, and this is also at the top. Now this line which is actually going horizontally in the right hand side view will be dotted, and this will give us the projection that we have to carry in the top view. So let's draw these things. So these 2 points are basically representing this particular line. So let's draw that. And the boundary, this particular slant face, and this is line connecting to these 2 points. Now this will be solid because for any object the boundary would always be solid. And we would have this particular surface as solid, and a line representing this would be a dotted line. So let me draw that. Now what we need to have is that projections associated to this point and this point. So as this point and this point, we need to take it back to the top view, and that's where we'll be able to locate where exactly these points are over here, and accordingly we'll have to make the dark lines to represent the top view complete. So let me carry these projections, this point, this point, this point, this point, onto the top view. Okay, now we have these projections, we have taken those. Now the extent of this particular object, so this is where the dotted line is coming up until this point, which means this particular section inside the diagram would be visible. That means I'll have to draw a solid line over here and a solid line from this point like this. So let me draw that. That will give you a visualization of the object. Now, as these points are on the slant surface, we had to carry the projections from the right hand side view. Now again, in this view also there won't be any hidden lines, but if this top view is making sense to you, at the top, this is the surface, these are the two which are here, this is the one which is here, and these are the two surfaces which are on the side, and this particular portion is a slant surface. That means sloping down, tapering down until this point, which is, and this one is again a flat surface parallel to the base. So this is how our top view is completed. This is how our front view is, and this is how our right hand side view is. So let me take a quick minute to name these things and give the dimensions here. Okay, so this is how your final object would look like. Thank you for watching this video. We at Graphics Desk committed to spread the knowledge. Be a part of this journey, share this video and spread the knowledge. Until next time, bye.